Okay, good morning, everyone. I'm here with my group to present our final thesis presentation for the topic, Mining Python API Usage Patterns. This presentation is going to be delivered by Nehal, Nadi, Elzahar, Menna Tageldien, Dina Bishr, and Mariam. This is under the supervision of Dr. Ahmed Rafea and Dr. Nadi. So the problem definition is that developers struggle to find concise, clear code examples while writing code. Studies have shown that 15 to 35% of developers' time is spent on the web while writing code. So our goal is to help developers by providing an IDE-based API example assistance tool through mining Python API usage patterns. And our outcomes are a research paper to document our journey and an IDE plugin. First, we need to define what we mean by pattern mining. By pattern mining, we mean identifying rules that describe specific patterns within the data. In our case, it can be used to identify APIs that typically occur together. This is an example of how our IDE plugin should look like. Given a pandas data frame, the developer here doesn't know how to normalize it and how to use the API min-max scaler. So our tool here is initiated using a keyboard shortcut, and a window pops up on the right, as we can see, with a single example of how to use this API. So in more formal words, we have the input and the output. The input is a query API from the user, and the output would be a concise common usage example. This is done through a large code corpus and mining Python API usage patterns. So we've done a literature survey of the already existing tools that provide similar functionalities to our project. First one we have is Program Creek. Program Creek is a website that provides Python API examples and how to use them from open source GitHub repositories. And the top examples are the ones that have the most upvotes from the users. The second one we have is Grapper. Grapper is a Google Chrome extension that shows code snippets according to the most similar to the programmer's search. Next one we have is Aroma. Aroma is an example assistance tool that takes as an input a single code snippet. In our case, it can be a single API method, and outputs to the user a ranked list of examples. The final one we have is EG. EG is another example assistance tool, and it's integrated into Facebook internal code search tool. It mines a given code base to show API usage examples. Now I'll walk you through our methodology throughout this project. So the first thing we did is that we mined GitHub repositories and we selected and cloned code snippets. Next, we used we took an API query as a user input, and we used that API query to search in the extracted and filtered code snippets. And we use that as an input to our tool, which is called API Wizard, which uses pattern mining to generate complete code examples. Next, we compared and evaluated our results. And finally, we integrated our tool as an IDE plugin. Now we'll talk about each of these phases separately, and we'll start with Nadi.
Now I'll go over the first phase of our project, which is the data extraction part. So here are the milestones for data extraction. First, we collect GitHub repositories, and this is done according to our chosen selection criteria, which we'll go over in the next slide. Next, we clone the repositories and extract Python files from them. Finally, we create code snippets from the Python files we extracted, and then we filter those snippets to find specific APIs. And the reason we create code snippets is because our tool, API Wizard, takes code snippets as input and not whole files. So this is our selection criteria for the repos. First, all of our repositories use the Python language. They're all updated after Jan 1st, 2020 to avoid having any outdated APIs in the code. They have at least 10 stars. We excluded the forks to avoid having near duplicate code. And finally, for the licenses, there were 12 recommended licenses according to the RepoRepo research paper. out of which we've chosen the 5 least restrictive open source licenses to avoid having copyright issues with the code examples we generate. After applying this criteria, we have 64,009 repositories. However, according to some storage constraints that we faced, we were only able to clone around 6,000 repositories, which were randomly selected, out of which we've created around 2 million snippets and filtered with about 75 APIs. So the first step for creating the snippets is to parse the Python files using the Python ASD library. And this is a sample input file from our dataset. Out of each file, we extract the import from statements, import statements, the function definitions, and the main functions. And if a Python file does not have any functions, we take the whole file as one snippet. The second step is to create the snippets after parsing. So this is the same file we've just shown. Out of this file, we'll create 2 snippets as shown. Each snippet has a copy of all the import statements at the beginning of the file, and then one function, either a method or a main function. The third and final step is to filter the snippets to find specific APIs. And this is also done using the Python ASD library. We parse the snippets to find the function definitions, and then we search for the API call inside the function. And after we find this API, we copy the file into another directory to group them together. And the reason we filter them is to facilitate the next steps of recognizing the usage patterns of each API, and also to have an idea of how many examples we have for each API we're testing with. So each API has an average of 110 examples, but some have over 700 examples. And now I'll leave you with Menna and Dina to discuss the second part of our project.
Okay, so given a set of filtered code snippets that is filtered based on the user API query, we use pattern mining to find the most common usage patterns between the code snippets. Then we generate complete code examples to the user. So our tool, API Wizard, uses the same approach as EG. EG is an internal code assistance tool that takes 2 inputs, an API query method, and uses a large code corpus of Python code snippets. Then through pattern mining, it outputs a set of synthesized code examples. However, EG has some limitations. For example, it is only tested on 6 libraries. It is also a standalone tool, meaning it's not part of an IDE. And we wanted to evaluate this pattern-based idea more, so we had to re-implement EG since it's not open source. An API Wizard uses the same approach as EG and tries to overcome its limitations.
Okay, so in more detail, the API Wizard takes a set of filtered code snippets as input, where each code snippet is represented as an AST. Then we find the common patterns between the different ASTs using the pattern mining tool GSpan. GSpan outputs the patterns that exist in at least 50% of the trees. And then we input those patterns. We remove from those patterns the subtrees that are part of larger trees in order to obtain the maximal frequent subtrees. Next, we generate an incomplete code template that contains placeholders that need to be filled in order to finally generate a complete code example. So I'll now walk you through a complete example to illustrate how API Wizard would work. So first, given 6 code snippets as input, let's assume that the user wants an example of the API split. So as we can see in this example, both APIs split and pop appear together in 3 of the 6 examples. So we'd expect that they both appear in the final example. So to achieve this final output, we generate an AST tree for each of the 6 code snippets, and we abstract it from any variable names or parameters in order to maximize the pattern generated by the GSpan tool. Next, for this specific example, the GSpan tool produced around 85 frequent patterns, from which we remove any patterns that do not contain API names in order to, because they would generate meaningless code. So we end up with 70 meaningful frequent patterns. And then we remove from them the subtrees. And by subtree, I mean that a set of vertices and edges are a subset of other larger trees, which finally leaves us with 2 maximal frequent subtrees for this specific example. So now, in order to have a complete example, we need the variable names and parameters. So we fill the nodes that should have contained variable names or parameters with placeholders, as we can see in this diagram. And below is the initial code template of how the example would look like. So next, for each placeholder, we need to fill it with real variable names. So we compare each placeholder with the corresponding variable name, and we keep account of the number of times the variable name appeared in the input example. So for instance, in the first code template, for placeholder 0, it was matched to the variable name lines 2 times, and it was matched with the variable name part 1 time. So we end up selecting the variable name with the highest score, which is the first one, and we repeat the process for all the placeholders until we obtain all the variable names. So finally, we have a complete tree, and then when we convert this tree back into code, we get a complete code example with the most representative variable names, and it gives the user an indication of how to use the split API along with the pop API. So now I'll leave you with Menna and Nehal to discuss the evaluation part.
So to eventually evaluate our tool, we compared our results to an already existing tool that provides API usage example assistance. This tool is Aroma that we mentioned in our literature survey. We tried to compare our results to other tools in the literature, such as Gripper and Program Creek. However, both didn't generate examples for most of the APIs that we tested our tool on. So for example, Gripper's data is based on crowdsourcing, where users can suggest examples for how to use APIs. That's why Gripper doesn't provide enough data that we can rely on in our evaluation process. And as for Program Creek, it's a website where you can search by a Python module name, but similarly, Program Creek didn't provide the needed modules, so we couldn't benefit from it. We also tried to compare our results to the official documentation. However, most of the API's documentations don't provide examples on the usage of the API with the functions that are usually associated with it. Some only list these functions, but they don't show how the association happens. So going back to Aroma, Aroma is a code recommendation tool that takes as input a partial code snippet, and that in our case would be a single line of code containing the query API. And it also takes a large code corpus of Python code snippets filtered by the query API. This input is fed to the Aroma algorithm, which is based on structural code search, and the output is a set of recommended code examples. So going to the evaluation metrics, we use the same metrics used to evaluate Aroma, which are conciseness, relevancy, and representativeness. As for conciseness, it's measured by counting the number of lines in a generated example, and the more the number of lines is, the worse the conciseness is. And as for relevancy, it represents how relevant the surrounding code in an example is with respect to the understanding the usage of the query API. And relevancy is measured by a ratio of the number of lines, of the number of relevant lines in an example to the number of total lines. We have defined the following criteria in order to determine if a line is relevant to the query API or not. So first, if a line contains the query method itself, this means this line is relevant. So for example, here the query method is randint, and this means the line containing randint is definitely relevant. And as for the second criteria, if a line contains a method that's usually associated with the query API according to the official documentation, it means this line is relevant. So for example, here, the line containing fit transform is also relevant because fit transform is usually associated with min-max scalar. As for the last criteria, if a line imports a library that's needed by the query API, this means this line is relevant. So for example, here we need to create an array, so import NumPy. That means the line containing NumPy is in which we import NumPy is also relevant. And as for the last evaluation metric, which is representativeness, it's measured by a counting score that the tool assigns to a generated example. And this score represents how frequently other code snippets in the corpus match the generated example. And the higher this score is, the better the rank. So to demonstrate, imagine here that the query API is A, and we have a code corpus that contains 6 code snippets filtered by this query API. And the generated example contains a pattern which is ABC. This pattern is generated using 3 out of the 6 code snippets in the corpus, which means the representativeness is 3 out of 6. For the evaluation setup, we tested on Python APIs from 3 domains: machine learning, data analysis, and web development, because these are 3 top domains that uses Python nowadays, according to Python Software Foundation of JetBrains. And from these 3 domains, we tested on 10 libraries, which are listed here. And now we will move to the results with Nehal.
Okay, now moving forward to results of our evaluation. First, Aroma, as we mentioned, is open source, so its code is available for public use. So running it was our first steps to go through with evaluation. But when we tried to look for the available source code, we found that it only works on Java code, but it was stated in the research paper that it can work with Python code and other programming languages. So to be able to have to support Python code, we extended it by having Python parser. So from now on, we'll mention it by aroma to distinguish which version we are using. Then we tested on different APIs to include frequently and not frequently used APIs from the mentioned libraries that Menna mentioned earlier. And we ended up testing on 40 APIs. And here is an example for one of the APIs we tested on, which is min-max scaler. At the top, we can see that the output for Bioroma, which is a lengthy code example that shows the query API highlighted in the red box, which is min-max scaler and other related functions. And at the bottom, we can see the returned code example for API wizard, which is also a code example, but it's more concise. And it also have the query API and other relevant functions. And here is a summary for the results obtained from testing on different APIs. Here we can see on the left the results for conciseness, and it shows that API wizard in general returns more concise code with less number of lines per code example, as conciseness is measured in number of lines per code. As we can see here, API wizard, the median is around 5 lines of code per example. And for Bioroma, it's double this time for its median, double this number for its median. It shows around 10 lines of code per example. And then moving forward to relevancy and representativeness, because conciseness as its own, it doesn't indicate it's a good example. It also needs to be concise and relevant at the same time. So relevancy and representativeness both are measured in percentage. And we can see here that representativeness and relevancy both have, for API wizard, both have higher results, which indicate better performance for API wizard. So to conclude the obtained results, we can see that API wizard in general have better performance, which indicates it has better code examples for the developers that can use easily. And now moving forward to the IDE plugin, which is our final step for our workflow pipeline. We use the Visual Studio Code to include our plugin, and now we'll show a demo for that. Here's an example of a code that a developer tries to have. It has specific data and trying to scale it and train it with linear regression models and have prediction and show the output. First, it's trying to scale this data with using min-max scaler. It tries to highlight it, and by a specific shortcut keyboard, it trigger API wizard, which at this case is Control-Shift-P. It triggers API wizard. And here the developer can easily mimic the provided example. It first have the libraries to include and then tries to copy the structure of the example. Okay, now moving forward, it then tries to train a linear regression model with the scale data, and using linear regression, doing the same process again. It tries to trigger the API wizard with highlighting the API needed and doing a specific shortcut by the keyboard. And then it shows the example, and we can see here at the bottom, it shows the background procedures that happen to provide this example, like converting code snippets to AST and all the workflow of providing the example. And again, it tries to mimic the provided example. And then it like completes the code and having results for this code, and it works. Like, yeah, it shows the results at the end. So now we'll move forward to contribution.
Okay, so in conclusion of the results discussed, we successfully re-implemented EG and came up with our tool API Wizard, which is an open source tool. API Wizard was tested on more libraries compared to EG. It is also integrated into an IDE plugin, which enhances the user experience. And API Wizard finally outperformed Aroma in the 3 evaluation metrics: representativeness, conciseness, and relevancy. However, API Wizard has some limitations that we think that should be included in the future work. So first, API Wizard sometimes fails to generate a complete pattern. For example, this results in generating incomplete line. For example, in the first line, the brackets for the API call concat was not generated. Also, in the second line, we can see the placeholder appears because we complete the AST tree pattern with extra placeholder nodes to be able to generate code. However, the generated code failed to match the placeholder with a variable name because it doesn't exist in the input examples. And this is why we see the placeholder. Also, due to the high variance in the dataset, specifically in how the parameters are written, API Wizard sometimes fails to find the most common parameters used in the call for the API. For example, concat usually takes 2 parameters. However, in this example, it didn't generate the 2 parameters. API Wizard also doesn't take into consideration the logical order of the lines. For example, here we can see that the S2 assignment came after using it as a parameter in the API call, which is wrong. We also wanted to enhance the user interface of the IDE, and we wanted to include the user study to evaluate the quality of generated code examples.
Okay, here's a summary of our pipeline of our project. So we started with data extraction, and then we moved into the implementation of our tool, API Wizard. Next, we evaluated API Wizard by comparing it with PyAroma. And finally, we integrated it into VS Code as an IDE plugin. And that's it. Thank you.